Okay, this video is going to go over synthetic division. We're going to illustrate this concept with an example. Here's the example. Determine x to the third minus 8 divided by x minus 2. Now if you were to do this the long way, you'd have x minus 2 on the outside of the division bar. Then x to the third. Now since there's no x squared term, that'd be plus 0x squared. Since there's no just x term, that'd be plus 0x and then minus 8. You have to account for every x term between x to the third and the constant, or else you're going to end up making a mistake. So now we multiply x by x squared to get x to the third. Now x squared times minus 2 would be minus 2x. So now that we subtract, x cubed minus x cubed would be 0. 0x squared minus negative 2x squared would be 2x squared.
Mommy.
Alright, so now let's bring down your 0x. We multiply x by 2x to get 2x to the second. 2x times minus 2 would be minus 4x. So now if we subtract, that gives us, those cancel out, 0 minus negative 4x would be positive 4x, then minus 8. Now you multiply x by positive 4 to get 4x. And 4 times the minus 2 would be minus 8. So if you notice, you have 0 as a remainder after you subtract. So x to the third minus 8 divided by x minus 2 is equal to x squared plus 2x plus 4. Now that was the long way to do it. That's what we call long division. We're going to learn today a concept called synthetic division. Alright, to work out the same problem, x to the third minus 8 over x minus 2 using synthetic division. First thing we have to do is take whatever we're dividing by, the x minus 2, and solve it for x. In which case it'd be x equals 2. Now synthetic division only works whenever what we're dividing by, our divisor, is a linear term. If we were dividing by a quadratic or a cubic function or something, then it wouldn't work. This only works whenever our divisor is a linear binomial. So now that we've solved our divisor for x, we can set up synthetic division. Alright, so now to set up synthetic division, take the number we solved for, put it in a box, and write our coefficient. Our coefficient in front of x to the third was 1. There's no x squared term, so that coefficient is 0. Likewise for just x, and our constant was minus 8. So now drop our leading coefficient, which is 1. 1 times 2 was 2. 0 plus 2 is 2. 2 times 2 is 4. Bring the 4 over. 0 plus 4 gives you 4. Now we multiply again. 4 times 2 is 8. Negative 8 plus 8 is 0. Now our last term, our last number is always our remainder. We have a remainder of 0. So we would have, so what we get when we divide is just, we have a constant of 4, which means our 2 is our coefficient in front of x. And our 1 is our coefficient in front of x squared. So that means we have x to the third minus 8 over x minus 2 is equal to x squared plus 2x plus 4. Or you can rewrite this as x to the third minus 8 is equal to, we get when we multiply these terms together, multiply our divisor by our quotient. And x to the third minus 8 is equal to x minus 2 times x squared plus 4 plus, why do I keep writing 4x? It should be 2x plus 4. So, we're going to use synthetic division to divide this polynomial. Okay, if you divide, or if you set x plus 2 equal to 0 and solve for it, you'll get that x is equal to negative 2. So now we write our coefficients. Our coefficient from x to the third is 5. Next coefficient is negative 6, then negative 28, and then minus 2. Bring down the 5. 5 times our number when we solved for x, which was negative 2. 5 times negative 2 is negative 10. Negative 6 plus negative 10 is negative 16. Negative 16 times negative 2 would be positive 32. Negative 28 plus 32 is 4. 4 times negative 2 is negative 8. Negative 2 plus negative 8 rather is negative 10. So if we notice, we have a remainder of 10. So that means what we get when we divide by x plus 2, our quotient would be, have a constant of 4, the x term would have a coefficient of negative 16, and the x squared term would have a coefficient of 5. So, our 5x to the third minus 6x squared minus 28x minus 2 all over x plus 2. This is equal to 5x squared minus 16x plus 4 plus negative 10 over x plus 2. Or if you don't like having this negative 10 over x plus 2, you can multiply both sides by x plus 2. And that would give us, after we multiply both sides by x plus 2, we would just have that our original function, the 5x to the third minus 6x squared minus 28x minus 2 is equal to x plus 2 times our quotient 5x squared minus 16x plus 4, and then minus our remainder of 10. Here's something we call the remainder theorem. When you have some function f of x, and you divide it by some factor, x minus k. You know how we take x minus k and we solve it for this number k? If we put it in parentheses, x equals k. If we take that k and plug it into here, into our function, that will give us our remainder. Alright, here's an example that if f of x is equal to this quartic function, use the remainder theorem to find f of negative 3. Remember what this means, since we're talking about f of negative 3. What's the remainder when you take that function f of x, that quartic function? What happens when you divide it by x plus 3? Because remember, if you were to take this x plus 3 and solve it for x, that's where we get the negative 3. So when you divide this polynomial here, when you divide it by x plus 3, what's your remainder? So we're going to plug negative 3 in. So if you plug in negative 3, you would have, so f of negative 3 equals negative, then negative 3 raised to the 4th plus 3 times negative 3 squared, then minus 4 times negative 3, then minus 5. Alright, so this would be equal to, you have negative 3 raised to the 4th, which is positive 81, but that's negative, so it would be negative 81. Then negative 3 squared is 9. Positive 9 times 3 would be positive 27, so plus 27. Then negative 4 times negative 3 would be positive 12. Then minus 5. So this, if you add it all up, should be equal to minus 47. So the remainder, when you divide that quartic function negative x to the 4th plus 3x squared minus 4x minus 5, when you divide that by x plus 3, your remainder would be 47. Alright, remember, a 0 root or solution of a function is simply a function, a number where f of x is equal to 0. If you have some number that you can plug in, make it equal to 0, make the function equal to 0, then that number is a root or solution or 0 to our function. There are a couple of ways to determine if our potential factor k is a 0. Pretty much, if you want to determine whether a number is a 0 of a function, you can use synthetic division to divide it, or you can just plug it directly into our function. If our remainder is 0, then that number k is a solution to our function. If it's not 0, then that number k is not a solution. So here's a two-part example. Determine whether a given number k is a 0 of f of x. So, like for part A, if you want to use the remainder theorem, you can just plug in 1. So it'd be 1 to the 3rd minus 4 times 1 squared plus 9 times 1 and then minus 6. So 1 to the 3rd is 1, minus 4 times 1 is 4, because 1 squared is 1, plus 9 times 1 is 9, then minus 6. 1 minus 4 is negative 3, plus 9 is 6, minus 6 is 0. So, for part A, you say yes, 1 is a factor of this, or 1 is a solution to this equation. I mean, if you wanted to do synthetic division, which I think is what your textbook does, you could set up like this. You could bring down the 1. 1 times 1 is 1. Negative 4 plus 1 would be negative 3. Negative 3 times 1 would be negative 3. 9 plus negative 3 would be positive 6. 6 times 1 is 6. And look, you still get a remainder of 0. So, either way, you can say yes. 1 is a factor of x to the 3rd minus 4x squared plus 9x minus 6. Now for part B, f of x equals x to the 4th plus x squared minus 3x plus 1. So, you can plug negative 1 into our function. So instead of x to the 4th, it would be negative 1 to the 4th. Instead of x squared, it would be negative 1 squared. Instead of minus 3 times x, would be minus 3 times negative 1, and then plus 1. So negative 1 to the 4th is positive 1. Negative 1 squared is positive 1, so 1 plus 1. Then negative 3 times negative 1 would be positive 3. And then plus 1. Tells you that the remainder would be 6. So no, negative 1 is not a factor of this function.